Hi then, welcome guys to my latest video in the series of videos on differentiation for our Year 2 A-Level. So by now you should have watched the videos on chain rule, differentiating standard functions, and you would have looked now at differentiating product rule, and thank you for your assignments this week. For that, it's been really great to see how well you've been getting on with that. So there's one other rule to do with differentiation that we're going to look at today, and that's going to be the quotient rule. And you can see that I've written a rule up here that we're going to be using, and quotient meaning fraction. And we're going to look at how we differentiate something like question number 1 here, where we have a function divided by another function. So we call the top u and v, similar to how we did with the product rule. Differentiate both bits separately, and then this is the formula that we have to chuck them into. A bit more complicated, a bit more going on with this than the product rule. You do get given a version of this though in exam, but you'll learn this in the end, so don't worry too much at the moment. So we set this up exactly as we have done before, that we define what is u, so that would always be the thing on the top, and what is v. And you differentiate both bits individually. And then it's just a matter of putting them into the formula, so it will seem reasonably sort of straightforward to begin with. Now we have to multiply v with the differential of u first of all, so I've got to make sure I times these two things together. For neatness, I'm going to put the 2 in front of the 3x minus 4 and use brackets. Then the formula says that we subtract, that's a critical part of this, and we multiply the other pairing of u with dv dx, so we're going to times these two things together. And again, for neatness, I'm going to put the 3 in front of the 2x plus 1. But the whole thing is then going to be divided by v squared, so that's going to be 3x minus 4 all squared. And again, we could just leave it there, that we have differentiated it, but it's always worth just seeing if there's some factorising or simplifying. On the top, I would look at multiplying out these brackets because there's like terms. I've got terms in x here that can collect together, but I wouldn't multiply out the denominator. This is factorised, so leave that as it is. So if we have a go at multiplying out the top, just be careful with that negative there, that you don't make any mistakes with negatives. Leaving that factorised because it was factorised. The top wasn't factorised, so that's why I expanded it to c. And actually I've got a nice thing here, the 6x's cancel out. So my final answer is minus 11 over 3x minus 4 squared. So that's our first example done. I'll make sure I just put dy by dx next to it, just highlight my answer. Okay, let's have a look at our second question. This time we've got e to the 2x on the top, and on the bottom we've got 5x plus 1. So same as the product rule, we're going to differentiate both of these individually. E to the 2x will need a little bit of chain rule, but that will become 2e to the 2x. As with the product rule, if you feel that you need to just do a chain rule question somewhere else just to make sure you're happy, then please do so. And you might want to look back at those videos. I'm not expecting us to be totally expert just yet, but you'll be getting better every time. Now, because I've turned the page, just realised I haven't got the formula in front of me, but I've got to times v with ddx. I've got to times these two things together. So we've got the 5x plus 1 times by the 2e to the 2x. Don't particularly like the 2 stuck in the middle there, but we'll work that out in a minute. Then we subtract u times dv dx times these things together. I will just put the 5 in front. All divided by v squared. So as there's a multiple terms there, put it in brackets. Now I am going to tidy up the top. I've got a common factor of e to the 2x on the top, so we're going to sort that out. Use my squared brackets again. And actually, if we look at this first term, we're multiplying by 2 lots of 5x plus 1. So I'm just going to multiply that out straight away to be 10x plus 2. And then for the second term, it's being times by negative 5. And because the 2 and the negative 5 can be collected together, that's why I multiplied out this bit here. So finish up our final answer. My square brackets, you can see some tidying up, but I'm going to just put those square brackets in front of the e. I think that'd be a little bit neater again. So we're going to have 10x minus 3, lots of e to the 2x, all over 5x plus 1 squared. Okay, just one last example show before I'm going to give you some questions to try yourself. I just thought I'd do an example with a little bit of trig involved. So we've got our u is sine x and the v is going to be 3x plus 1 all squared. So differentiate sine x. As always, keep pausing the video if you want to just think ahead as to what answers are going to be. And then differentiate here. This is going to need a little bit of chain rule. It's a nice linear bracket, so I'm going to end up timesing the 2 with the 3 as it's the derivative of the bracket. So I'll have 6 lots of 3x plus 1 to the power of 1. So then I'm ready, got my constituent parts to put into dy by dx. I've got times v with du dx. So we're going to have 3x plus 1 squared times by the cos x. Then we subtract times in these two things together. I'll put the trig bit last just so we know that the 6 lots of 3x plus 1 is a factor and not sine of them. Put the x in the bracket there, just because I can, really. And then it's going to be over v squared. So v already was 3x plus 1 squared, and then that's going to be squared again. So at the moment, I'll have to just maybe put some brackets around it, but it would have been probably neater just to put that to the power of 4 straight away. But I do want to tidy up my answers as always. Again, could just stop there, but if there's a little bit of tidy up, we can do. And in this case, we've got a 3x plus 1 bracket on the top and another 3x plus 1. So I'm just looking at the top because the bottom is factorised. So on the top, we've got a 3x plus 1 as a common factor. Then I'm going to open up and then what have I got to get? I need another bracket and a cos x. Then looking at my second term, I've got the minus. I've already taken out the 3x plus 1, so I've got 6 lots of sine x. And then on the bottom, I'll sort that out now. That's 3x plus 1 to the power of 4. So that's nice and factorised, and actually the beauty of this, of course, is on the top we have a factor of 3x plus 1, and on the bottom we have a factor of 3x plus 1, so actually they can cancel each other out. So I think on the top there's probably not much else I can do, so this is just the contents of my squared bracket. But that 3x plus 1 there, cancelling out with one of those there, so we've just got a bracket cubed on the bottom. Okay, so there's some examples for you to have a look at. Whilst we've got this video going, here are some questions for you. So pause the video now and write down the questions. They get perhaps a little bit more tricky towards the end, but the first couple should be quite good for you. So pause the video and then now I'm going to show you the solutions. Okay, question number 1. I've simplified my answer straight away for you. Question number 2, this is probably what you got initially for dy by dx, and my purple writing now is my simplified answer. So I thought, I've not shown you my full workings, which you should of course have done. I want to see your u's and your v's, what individual differentials you get, but that's probably what you got initially. That's the simplified answer. Same again with question 3. This is probably how you wrote it. Maybe some of these things you might have written in a different order. But by the time you factorise out, there's an e to the x as a common factor. There's also a bracket squared as a common factor on the top to take out. This is what you should get. And there's the common factor of 5x minus 3 squared. The e to the x's that get taken out, cancel out with one of them down here because that was e to the x all squared. And then the last couple, I got ahead of myself, so just ignore the mistake. Question number 4, that's probably your answer, and looking at this, there is really not much you can do. You can multiply out this bracket and have loads of sine 3x terms, but they're not going to collect together with the cos 3x's. There is some work with trig that might possibly tidy that up in time to come, but not to worry about at the moment. And then the last one, question number 5, just remind yourself of the question. I'm sure you've got it written in front of you. Here it is. It had the natural logarithm of 3x over 5 minus 4x. When you differentiate that ln of 3x, you will get 3 over 3x, so that would simplify to 1 over x. So you probably times those two terms together. There is a double negative going on here, and then it's all over 5 minus 4x squared. I'm missing my squared. In terms of simplifying this, because I've got a fraction within a fraction, what I've just done here is multiplied the whole fraction by x over x. That's equivalent to 1, so times by 1 makes no difference. But if you have a look on the top, I've times this term by x, which cancels out that x, and this second term has been times by x. And then on the bottom, this has been times by x as well. I forgot my power of 2, which is rather annoying. But there we go, that's the quotient rule for you. See how you get on with that. I shall give you some practice work to do as well as those 5 that you've just done, and also set you a little assignment with a few questions that hopefully you can take a photo and send to me, and if I can, I'll give you some verbal feedback as well. So good to see some of you last week, going to see more of you this week. So yeah, see you soon guys, bye.